As Caroline mentioned, I do work for Telstra. However, I have no approval from legal or marketing, so today I'm Open Kilda. Turn off the cameras. Joking. I do kind of want to give some insights into our experience with Kilda, a little bit about the Telstra programmable network, and some changes we're making and what our future roadmap is. Before I get started, anyone in the room actually ever hear of Open Kilda? Yeah, all the people that work for me. How about the rest of you? So we're hoping that at the end of today, this is an open source project that we can actually bring some of you on board and get a little more participation into the project. Remember I said no marketing was involved, so the slides are, actually they're really good. So what is Kilda? A year ago at this conference, Caroline gave me the opportunity to introduce this project to the world, basically. And at that time, we announced two things. We announced the project of Open Kilda, which at the heart is an OpenFlow controller. We also announced that we were making it or releasing it as an open source environment. So we wanted to build a community. We wanted to bring others into this project. It's a slight twist on a traditional OpenFlow controller, and we'll address that, its differences. At that same conference, Caroline asked me a question. She said, wait, everybody says OpenFlow is dead. Why are you guys still talking about OpenFlow? So I thought we'd address the elephant in the room here for a second and just answer the question, is OpenFlow dead? Any polls in the room? This is audience participation, by the way. Any polls in the room? Is OpenFlow dead? Is it not dead? It's kind of in between. Okay. So I see OpenFlow as kind of three main concepts, and this is going to get me in trouble with OpenFlow purists. But I see OpenFlow at the very high level as being a common switch definition. The fact that we can take a switch from any vendor, drop it into our network, and know that it will act and respond and perform based off a specification and a certification process allows us to create multi-vendor solutions that just have not been possible in the past. However, we have lots of different OpenFlow switches in our network, and I can't tell you a single one that actually implements the specification correctly. We struggle with leakage from 1.4 stuff showing up in the 1.3 spec and vice versa. But even with those challenges, we're able to take our software and modify and work around the deficiencies or the challenges that we're seeing in the implementations out there. So we still get the ability to create a massively multi-vendor network that would be very difficult to do in traditional solutions. Communication protocol. Yeah, you're all saying, do we really need a new communications protocols? How many different ways can we talk to switches today? I agree, we have way too many. I wish we could standardize on one, but we won't be able to. I still like the communication protocol, and my comment would be go back and see point one. It is a standard protocol that I can go across a multi-vendor solution and talk to any switch that is out there. Quick, easy, and somewhat efficient. Actually, not really efficient. There are problems with OpenFlow, though, let's face it. Probably the largest issue we have in an OpenFlow environment is this lovely team in Telstra called Security Operations, which whole goal is not to offer any products to customers. And the OpenFlow protocol has some challenges with authentication and authorization, let's be honest. It's you're either connected or you're not. We can do some things with client-side certs, but it's still not a perfect solution. We also, OpenFlow in general is a fire and forget. We send it a command, we cross our fingers, we do a little happy dance, we hope that it actually makes it to the switch and it does its job. We get no positive acknowledgement back from the switch that says, hey, I just processed this and it was okay. We get negatives back, but we don't get positives back. What does that mean? In code, we now have to build large state engines. We have to do complex logic. When we try to scale that horizontally, now we have to do synchronization between those state engines in order to make sure that we actually are getting the commands that we want in the switches that we want in the field. Perfect solution? Absolutely not. Go back and see point one. We still have a standard solution where I'm not tied to a single vendor. My third piece for OpenFlow switches, and to me, I don't actually know if this belongs in the standard or not, but it's the match-X switch. We come up with some wacky, crazy ideas for what we want to do in the core of our network. And with the MatchX switch, for the most part, we can go and implement that solution. If I can come up with a crazy idea, either within the spec or through an extension in OpenFlow, we can go and implement that idea in that switch. And if we're doing something standard, we know it's going to hit across our entire footprint that we have. We also have a wide range of switches. We have NPE switches, we have ASIC switches, we have FPGA switches. They all have different performance characteristics, cost characteristics. They fit at different levels in our network. And the fact that they all support that same standard makes it very easy for us. So do I believe that OpenFlow is dead? I hope not. If it is, keep me the MatchX switch. It keeps me happy, and honestly, my team says I'm never happy, so this is a good thing. So let's go back to what is OpenKilda. It's an OpenFlow switch at its heart. It goes back to, well, back in 2013, I was at PACnet. We got acquired by Telstra. We created an OpenFlow network. It was a large OpenFlow network, expand Australia, US, UK, Europe. Complete WAN, true OpenFlow, dark fiber, for the most part in between the links. And we've learned a lot of things about where OpenFlow works and where it doesn't work. When we were working through issues we had in that network, and it had a commercial controller at the time, what we found was all of the controllers in that one that we were looking at looked at the network at an individual switch by switch level. It didn't look at it at the macro level. It didn't see a network of switches. It would take an event, process event, make a decision. So the first thing we were trying to do with OpenFlow, or with OpenKilda when we first looked at it, was how do we determine if an event, definitively that event, actually has an effect on the network? Does it change the network graph? Do we need to trigger a reroute? Does it have a negative impact on the customer experience? Our latencies across that network are pretty huge, 150, 200 milliseconds, because our controller basically sits in Singapore at the moment, but I'm managing stuff all the way through the UK, Germany, France, and down to Australia. And it's somewhat limited in capacity, but we still want to get lots of telemetry data and be able to make decisions and correlate those events in real time. So the kind of design goal behind OpenKilda, how do we create a stream processing system? How do we create a correlation engine so that we can have more than one data point to make a decision? Does it actually trigger a network event? This is a WAN controller for the most part. It is not in the LAN. This is kind of a unique, I believe, a unique implementation for OpenFlow where we're doing this across a large network. And hopefully, it's all wrapped up in a nice, pretty extensible system so that we can make changes to it, modifications, and all those types of things. So why did we create this? So at first we thought we were smart. We thought we were going to create this cool system, we'd be able to solve all of our problems. And it was going to solve everything that we were facing at the point in time. That's the pretty answer. The truth of the matter is we're completely crazy. We all needed something to do to keep us away from our families. The joke in the office is you never realize how few friends you have until you have an obsession. So we spend way too much time working on this project. But we did it to combat a couple of specific issues. So the first, and I'll throw it out there, was to break vendor lock-in. Right? We always talked about, wouldn't it be nice to be able to create a routing protocol that matches the financial model rather than a financial model that matches the routing protocol? We have a large subsea cable asset, and we wanted to be able to utilize and monetize those assets in a very different way than standard routing protocols allowed us to monetize those solutions. We wanted to be able to take control back of the customer experience. Didn't want to keep going to the vendors and say, tell me what the experience should be. We wanted to be able to dictate and control and provide a customer experience that we were finding it difficult to do with the traditional vendors. We looked at, like I said, we were on a commercial controller. We looked at all the other controllers out there, and they all were kind of single processing systems. We were looking for something. We were trying to build something that hyperscaled, that allowed us to correlate multiple things together, multiple events together, was quick, was real time, and honestly put us in the driver's seat. And finally, we needed a product that was somewhat tightly coupled with the way we were selling it. So we already talked about being able to control the routing protocol, but Telstra Programmable Networks is a very graphical environment. You kind of draw your network, connect it all up, hit the deploy button, grab a beer, come back, and then the network's up and running. We wanted to have that same experience, and we needed to be able to carry some of that functionality through to the controller itself. So we kind of sat there and came up with this solution, which is we need to build a solution based on big data concepts. We need to build a network that has horizontal scale, essentially infinite horizontal scale. We need to be able to put bits of the controller, and I use controller very loosely in the sense of Kilda, but we needed to be able to put the controller across multiple regions. We need redundancy. We need all the things that carriers need from a carrier grade OpenFlow or SDN controller. So the network itself, or the controller itself, is kind of stacked off of this concept in the middle of this chart of Kafka. Kafka is a messaging queue. So first in, first out, messages come in. It's, in my opinion, a gorgeous messaging queue. It's log-based. It takes care of ensuring that message only gets processed once and all of those beautiful things. We can push a lot of messages through Kafka. Sitting above Kafka, we use something called Apache Storm. Storm is a real-time, event stream processing system that's real-time, not micro-batching. So the time that a message enters in and we can pull it out of the queue till the time we make a decision on that message, it's less than a millisecond. So we're making real-time decisions as messages come through. It also has branching logic and joining logic, so we can start to build correlations as we see multiple events come into the system. It's modular in the sense that we write these things called storm topologies, and I will say as a network operator, the word topology gets overused way too much. But we have these things called storm topologies that are basically microservices, and they control our path computation engine. They control when we determine if a topology change is required, how we react on those required, or on those events. So if we need to change something, we just have to write a new topology to stick inside there. And then we have a nice pretty northbound interface, we have a GUI, we have time series database and all those things to collect it. You will see Floodlight down at the bottom, and we decided to take a shortcut in how we talk to the OpenFlow switches. Floodlight, we pretty much strip everything out. If anyone from Floodlight's here, I'm sorry. But we pretty much strip everything out, and we use Floodlight as a big translator to go from OpenFlow to our Kafka messaging format and then back again. So we can have lots of floodlights deployed. They all talk to different switches. Some of them are fit for purpose, but they're all listening to different messaging queues and pulling messages out of the queue. Everyone likes nice, pretty pictures. This is actually the production network for Telstra's TPN at the moment. This is the way that the interface works. I will say when we first built Kilda, we had absolutely no intention of building a GUI interface. We're all a bunch of CLI junkies and Rust interface people, and hell, we didn't need a GUI. What do you need? We then quickly realized that we need operations people that would much rather have a screen pop up and something could turn red, for example, when it breaks. And this is the interface that we've kind of put in front of Kilda from our day-to-day operations interface. Deployment pipelines. We've been talking about automated deployment. Any carriers here? Anyone? So does anybody actually do real-time, complete, continuous deployment? Let's talk. We don't. We would like to. We're not quite there yet. We're doing kind of scheduled deployments. They happen twice a week, which for carrier speed is still light years ahead of what most carriers are doing, and other parts of Telstra even. So we do deployments kind of twice a week. And the way we can do that is we have a kind of complete package that runs on every developer's workstation. They can do full testing, integration testing, acceptance testing, the whole mess. It pushes up into our GitHub repos. We have a single button we push inside Jenkins. Jenkins is kind of a script management system is the best way to put it. You push a single button, they go directly into the production system. A bunch of canary tests run on the back end, and all of a sudden we've pushed our deployments out there. We're not quite there yet to do hit lists where we can have 2 versions running and go from an A to B state, but that's kind of in our next, one of our roadmap items. So Speaking of test pipelines, there is a typo on the screen. If I was really good, I would tell you it was planned, so I can talk about the fact of not going through testing before you actually release something to production. And the truth is, we were sitting in a bar last night and someone missed it. But I did want to spend a little bit of time and tell a couple of the stories, because the initial title of this was, a day in the life. So April 1st, a very auspicious day because it's April Fool's Day. We decide we're going to migrate the entire production network, 220 switches, from the existing controller that's been in operation for 4 years onto OpenFlow. And we practice this, and we practice this. We can do this in our sleep. We got teams, everyone knows what they're doing. We show up in the office about 6 o'clock. We're supposed to start at 7. All of a sudden it's 8:30, and we realize it hasn't finished compiling yet. So we're kind of sitting there going, this may or may not be the greatest start to this process when we haven't even got the compilations completed yet. And compilation finishes about 9. We're still in our maintenance window. We start to do the migrations, and we're doing them pop by pop. There's roughly 40 pops in the network, doing pop by pop, and everything's going great. And again, we have a complete plan. We have backup plans. We have everything we need. We can go back to the original controller. And all of a sudden, one of the switches in Hong Kong decides not to connect to the controller, goes completely dark and goes offline. And at that moment, we all kind of panic. Well, I panic, the rest of the team stays calm. We have to take one of these new switches that we built Kilda for and put it into production before we're ready to put it in production. Call the data center team, get it put back into production. We continue to process. 2 days later, another switch does the same thing, goes offline. We're in the same situation. For the entire month of April, it was kind of hit and miss. We had lots of issues. I have to say this, I've worked in carriers my whole life. I walked into my boss's boss in Telstra and apologized for it. And she looked at me and she said, don't ever apologize for taking a risk. And at that moment, I knew that I had finally found the carrier that actually understood what it meant to be a technology company, not a carrier. And it was a really interesting experience. We had a few minor other incidences, like the time we decided to push 1 million messages into the Kafka queue at the same time because we had an infinite loop that we forgot to stop, which kind of took down the whole network. And she didn't tell me on that case it was okay to make a mistake. We do have a roadmap. This is more a slide just because I needed to add a filler. But we do have a pretty deep backlog. Most of it is about adding redundancy and scalability. This is truly an OpenFlow network across the WAN. So it's point-to-point E-line services. So we're trying to keep up in speed with what we can do in a traditional E-line kind of environment. I do want to call out one person. I don't know if he's here. There's a gentleman from NoviFlow named Kevin Austin. He's come into the community, has put together a community site for us. The address is here. We'd love you all to go take a look at it. More importantly, he put the presentation together last night out of my head, so thank you, Kevin, for that. And finally, there is a demo of Kilda at the NoviFlow booth. If you show up and you're really nice to Kevin, there's a few of these gorgeous sweatshirts or hoodies sitting there at the booth, and he will be more than willing to give you one of those for a chance to explain the system to you. We would like to see you join the community. We are trying to build a community around this, so if you have any questions, please come and find one of us. There's a bunch of us wearing these, and we'll answer any questions. Thank you.
Thank you very much, John. Well, yes, I would say do go to the booth, but are there any quick questions for John now? Okay, one there. Oh, yes.
John, what about what would be the impact if you would have to migrate to P4?
Great question. So we are playing around with P4. The reason why we built it in a modular environment, I kind of skipped that slide pretty quickly, is we also have an SNMP speaker, so we can get certain data from SNMP. We have a netconf speaker, so we can deal with some old legacy equipment. Putting a P4 runtime speaker, at least inside of there, not very difficult to do, and we're able to, from a open Kilda perspective, easily pull messages out of the Kafka bus, convert them into a P4 message, and shove them down to the switch. The more interesting thing for me for P4 is when can we start to do some of the more interesting things where I can write micro functions and things like that and run them directly on the switch. So I mentioned we're in an E-line kind of environment. We want to change that, offer ELAN, E-tree, kind of go higher up in the stack, and that's where I think the interesting things from P4 come into play for us. But deploying it in the system, not that difficult, and there'll be a P4 speaker probably the next 3 to 4 months.
Okay, thank you very much indeed, John.